world. Today we are going to continue our series on GeoGPT, which is a powerful research assistant specifically designed for geoscientists, geologists, geophysicists, even geographers and GIS specialists. If you are anybody interested in working with geological tools, you find a lot of tools designed specifically for you in GeoGPT. And today we're going to talk about one which is quite interesting. That is the GeoGPT MapChat, which is more or less like a tool that allows you to interact and speak with a map and extract information from the map. And then some of the information you get from the map can further be used in other geospatial tools like Quantum GIS, ArcGIS, and so on and so forth. So, GeoGPT MapChat is an AI-powered tool for geological map analysis, and it allows interactive geological map interpretation using multimodal artificial intelligence. The structure is very simple. In my opinion, it is just 6 structures that you see. One is that you have recognition of a map with coordinates, which means you can work with map with coordinates, and then you can work with map without coordinates, and then you can interact with the map, ask questions and answer, and get answers for them. You can extract the legend, and you can also extract point from the map. And you can either upload the map, or usually it should be a very high resolution image, JPEG preferably, high resolution emphasized. And then you select the map, you ask your geological related questions, and also try to check how accurate the points are if you are working on points. Apart from that, you can do basic to advanced analysis of stratigraphy, formation, faults, and even the lithology. With maps with coordinate means those maps, they come with latitude and longitude data, which means they are in degrees, minutes, and seconds. So you need the map to be in degree, unit, and seconds. It's not working with decimal. Maybe that's going to be a new development as they move forward, but at the moment you have to use degree, minute, and seconds. And then you can, after using that, going to be a control for the point extraction or for polygon extraction, which you can do automatically or you can do by manual means. And then these control points that you use longitude and latitude for, you can edit them, move them around from time to time if you think they are not correct, at least for them to be correct, right? And then if you try to extract points from the map, you can export those points and then have them in a CSV file, which you can use on your other GIS tools. Simply for the one without coordinates, it just means you need to mark some control points, add some control points on the map as longitude and latitude values, and adjust the map accordingly, and then extract your spatial and information and legend. So like I already said, you can click on a legend to extract information about polygons or areas on the map, or dim an area on the map. You can even export the legend. You can control the density of what is being, I think it has 3 main focus when it comes to how dense the data should be. You can have a very sparse, medium, dense collection using that technology or that method. And then you can export your data as either JSON or not JSON or CSV. The caveat is very simple, and GeoGPT also recognizes this caveat. If the map will struggle if it is scanned and it is low resolution map. I've experienced that before, and so if you are using a map, I think you should use something over 750 dpi. That will be a very high resolution map, right? If the coordinates are unclear, then you are not going to get a very good result. And if the texture also is not good, these are just resolution related problems. And if you have multiple maps in one image, it's going to struggle a lot. So you need to often do some kind of tweaking, manual tweaking to them. So now we're going to head to GeoGPT and we're going to test this out in GeoGPT. So we go to GeoGPT. And then you get started. Click get started. And you are in GeoGPT and it's under research tool. If you come here, it's under MapChat. And they already have two templates uploaded already. So I will use them and I also use my own data as well. So let's start with the first option, which is with coordinate. If you click on this map, you can see that it's already reading the map for you, right? So you can ask several questions here. If you look here, there are three options. First, you have longitude, latitude extraction, which means you want to extract points. Polygon extraction, which means you want to extract polygons. Or provide a text description of the image. That should be the first thing to start with. So I'll click on provide a text description of the image. The map doesn't have a title, obviously it doesn't. But it shows geological map of an area and shows igneous stratigraphy, shows the geography of the area. And also the legend is showing the rock types from Ordovician to Carboniferous and Bonsogranite, Porphyritic granite. Okay, we can start querying this. Once that is done, we can say, for example, before we do the extraction, we can interact with the map. We can say which units are Cretaceous in age. Cretaceous in age. If you look on the map already, there are labels for all the ages. Obviously, there is no Cretaceous age here. So let's just test the intelligence. And it's going to analyze the map. Based on the geological map and legend provided, there are no units explicitly labeled as Cretaceous in age. The map shows various rock types and formations from different geological periods, but none of them are specifically identified as belonging to the Cretaceous period. To determine if any of the map units could be Cretaceous in age, we will need additional information, obviously. Right? Let's test it again and say show fault lines crossing the study area, and it's just going to pick out all the faults that have been labeled. So you have the fault here. This runs diagonally across the western part of the area, and that's this fault. So it's not picking the ones that are not labeled. So and it has picked 1, 2, 3, 4, 5 faults that have been labeled. These faults are represented by black lines with triangles pointing in the direction of displacement, right? That is okay. That means they are more or less like normal fault, right? There are no trust faults here. Maybe we should also ask it about something. So list map legend in the northwest zone. Let's see what it's going to list here. List map legends in the northwest zone. So this is northwest, so it's going to tell us we have quaternary represented by a white color. Yeah, so quaternary is white, more or less gray. We have Jurassic, we have Carboniferous, yeah, And those are the kind of interaction and many more that you can try with the map, and it can even return some Python code for you to try out with the map. Now, both this longitude and latitude extractions and polygon extractions work with a correct control point. So, if we want to do longitude extraction, we click on longitude extraction, and it's going to propose 4 points on the map. And already, if you drag this, you can click and drag. If you drag it to the appropriate place here, you already see that the longitude is 101 degrees 40 minutes, and here it is 150 minutes, right? And then you can drag this to the end as a control point, and it's going to use we know how many kilometers a degree is equivalent to, and vice versa. And then we just need to confirm that this is 50, this is 50, this is 10, this is 15, and then you confirm. Once that is confirmed, then you can start extracting positions from it. Let's assume you are going to extract all these red points. So the lens is going to focus on where you want to extract. If you click, it's going to extract it as a part of Carboniferous rock, which is shown in the yellow, with yellow in the legend, and also give you the latitude and longitude. Okay, let's go to the next one where we have the meta deposit. If you click here, yeah, it's porphyritic mosogranite, right? And that is the purple color. Let's go to the next one. We click on this one. That is not determinable because it's falling on a vein, I think. Yeah, the yellow ones are veins, right? So let's click also on this point and see. And that's Ordovician, right? So we have 4 points. We can even click extra points, like positions of some of the veins in the south. Let's click this guy. Yeah, and then click this guy, and maybe even click more points and see, and click more points. So once you click all the points, if you don't want the point, for example, this is point 9, the last one, you see that they also come with their labels, the names, right? If you don't want it, you can just click it and remove, and it will ask you if you really want to remove, and you say yes, and you can go back and add it, and that will be 10, because then the numbering has changed, right? So once you're done, you can also modify this point by clicking modify control points, and those will allow you to modify the coordinates, the longitude and latitude. So if you need to export everything, you just need to click here, check everything, and then you click on export, and that will export as a CSV file, and the result is here as a CSV file. You see, now this is a CSV file. So data, text to column, delete to comma, and then next, then finish. And now you can see all our points as being, except this point that is here, and you can go ahead and edit this, and then that. So okay, so we can save it and go back to our file. So because we already confirmed that, we can now use polygon extraction. So if we clear this and start a new shot, we can start a new, clear this, clear all those points, and do polygon extraction. And then that is dependent upon the legend. So if you click on the legend for the first point, is going to highlight the granitoids. All the granitoids in the area is going to be selected, and it's going to select the number of polygons that they are. So 1, 2, 3, 4, 5, 6, 7, 8, and maybe one small one I'm not seeing. If you want to highlight all the Ordovician rocks, if you come here, Ordovician is going to pick all the Ordovician rocks, right? And then with 19 polygons, right? If we want the porphyritic mosogranite, mosogranites are the medium. So more or less, if you want to just drag everything on, just click on the legend to select all of them. We already did for Jurassic, I think so. I think we already did for, okay, we never did for Jurassic. And then we can even do more. If it's going to, let me see if it's going to pick default. I doubt, but we can try. But it's polygon, so it's not going to pick default. Ultramafic rocks, and everything is selected here, right? It's done here, so you can just select them and then export, and this will be a JSON file. So JSON file export. It will ask you how dense do you want it to be. If it's very dense, you say let's go for medium. You can go for sparse, you can go for very dense. I'll go for medium, so I'll say medium and I'll confirm that, and that is downloaded as a JSON. I think we can check out in something like QGIS. I have my QGIS opened, and then I can drag that folder, that JSON file, download, and drag it into my QGIS. And you see, it has selected all the polygons, right? And maybe we can actually check for where this is in the world, right? Where it is in the world. So maybe we put on Google satellite map, and I saw it will be somewhere in China. So if you drag it down, you see the location of you see all the alluvial fans and the surrounding geology. Quite amazing, isn't it? And then you can say maybe fill it, just for seeing sake, right? And then say 5 and apply. That is the outline of those polygons. I think we can even check the properties here and see. And you see that's done everything, and also bring in the color code. We can convert the color code using table editing in any of the tools, or even group them according to so let's do something. Yeah, we style it. We style it back. Symbology, we fill it with color, and then we do categorized, and we choose name, and then we classify, and we choose value name, and we classify, and we can remove the first one, right? And we can apply, and you see now the same granitoid, and then you can play with the colors, and that is it. So discard. I'm not going to save that. So that is simply how it works with data with coordinates. So I can clear it. We can try again MapChat. Reload. If it doesn't have coordinates, it's simply a very simple thing to do, right? MapChat, you just click image example without coordinates, and then you have to fit in the coordinate point. So just the same way, like we did, yeah. Polygon extraction, point, and then add point, so if you had the point as control, if you know the coordinate here, you had it here, you put it the degrees, the minute, the seconds. Let's just play with this, because I don't know, it's somewhere in China, so we can try 0, 1. We can try the same number we did for the other one and say maybe 10, and then we had another point, and then if you know the so we say 50, 10. So that's, and then you can add as many points as possible. It's just like you georeferencing a map, like in QGIS or ArcGIS, right? So we can clear this, and we can And then once you do that, the rest of it is just the same process. Provide a text description of the image here, and it's going to do it. Says the title, talk about all the rock types. It's just like map reading, right? It's reading the map and giving you responses about feedback about the map, and you can ask all the questions. Where are the faults? Are there faults in the air? Stuff like that. The scale of the map, the fault systems. So it has even labeled them out without me even asking. And there is no inset to this one. So we can try the last part, which is using your own map, because I've been using the one inbuilt into GeoGPT, and you just to remove the doubt. So if you have a map, a PDF, and you want to like this kind of a map, this is not a very good map, but it's a very complex map. So if you have this kind of a map, you can make a sniping of this map, and then save it as a JPEG, right? So, but I already did the snipe. So start with map image with coordinates, and then I'll upload it. It's a map of Osun State in Nigeria, and it's going to read the map, right? We can start by saying provide a text description of the image, and it's going to do that. So if the aim of this work is to find to geolocate all the gold deposits in Osun State, which are shown in the yellow square here, right? So if you zoom, you see that there are some yellow squares all around on the map. Those are the location of gold deposits in Osun State, and then it's writing a very strong geological history of the area. That you have pegmatite, you have granodiorite, you have quartz diorite, you have syenite, you have shanokitic rocks, which are typically rocks in Nigeria because of the name from our Professor Oyawe. Granulite, amphibolite, gneiss, you have banded gneiss, you also have pegmatite. And then it has talked about the share zones where you have the faults, how weak they are. So one thing we can do here is we can also do extraction, and then it's going to give you a warning because it's going to tell you that you have to be sure of the positioning, right? So before you confirm, so I can drag this to the edge here, which is latitude. It's not going to change, so irrespective, because it's a vertical direction, so you need to be accurate. I can drag this one, the longitude one here, and we can read that from the map, right? So where is that map? So if we look here on the map, you see you have the location here, you also have the location here. So this is 5/1/27, and this is 4/11/27. This is 8/2/15, and this is 7/2/15, right? So we close that and we fill them in. 4/11/27, and this will be 5. No, it's 5 or 4. 5/1/27. That's quite good. And then 8/2/15, and then it's 7/2, and then 15, and then you confirm, right? Confirmation. This is a very poor resolution map, so I won't do it, and it's very complicated, so I won't go doing polygon extraction, but I can do point extraction. So I'm going to do point extractions. Let me look for the position of the gold. So start with this is one, and you see that the legend is not clear and the texture also is not good, so it will only give me the latitude and longitude. caveats of using low resolution images. And then I have 2 points, and it's going to be labeling all the points, right? So using the lens, I can follow them around. I can follow. So you need your legends to be very clear. That's the most obvious thing here. So if it is not clear, and then you have concentration of all the deposits somewhere here. And you see it has done that, and you can export that as you can export all of them as a CSV and have the result as CSV, right? So let me show you the caveat also. So if you try to do the polygon extraction, right, it's failed because no legend box found in the image because it's too small to read, right? So you need to find a way to fix that, and then it can read your map for you. If you click now, it's not going to select any polygon because it's all, the texture is not good enough, the resolution is bad. So this is MapChat in GeoGPT for you. It's a game changer for a lot of us that we struggle with geolocating or georeferencing old scanned map or maps that we found in the library. So try it out and let me know how it works for you. Meanwhile, I insist you listen to the ethical talks. Thank you. See you soon, and see you soon with another mind-blowing tool in GeoGPT. Bye bye. AI can help you think faster, but not think less. It can be your creative mirror, not your intellectual crutch. Let it support your curiosity, not suppress your judgment. Stay bold, stay ethical, and above all, stay curious. Click the like button, share the video with your friends, make comments on areas to improve, and if you have suggestions on other tools you want me to look at, let me know. Thank you, and stay blessed. Bye.